Okay, you can see I've got 6 different things that I need to factorise here. These are all using the difference of 2 squares. So where you have the form a squared take b squared equals bracket a plus b, close bracket, new bracket, a take b. That's what we're going to do with each of these things here. So looking at these, up the top left here, you can see I've got x squared take 4. So the x squared is like the a squared that's down here, and the negative 4 is like the negative b squared that I've got here. So really, to change it from the form I've got into a factorised form, I need to get the square root of x squared, which is x, put that in the first bracket, and I need to add the square root of 4, which is 2, and then I need to get the square root of x again and subtract the square root of 4. And so you can see it mirrors very closely what I've done here with the general form of that to get our answer. Okay, so that was the first one. Underneath here I've got 25 take x squared. It's just like the one above, only the x squared is on the right. Doesn't make any difference really. The square root of 25 is 5. The square root of x squared is x. And then 5 take x. Okay, exactly the same as what I did above, just that the x and the constant term are in different places. Now, neither 3k squared or 75 are square numbers. What I need to do here is I need to take out a common factor first. 3 goes into 3k squared, and 3 also goes into 75. So I'll take 3 out the front of a set of brackets and put inside here k squared take 25, because 3 times 25 is 75. Now you can see that just here, k squared take 25, that's the difference of 2 squares. So just keep the 3 where it is and put k plus 5 and k take 5 to factorise that fully. And I should put my equal signs in as well. Underneath, I've got a similar question. I need to find the number that I can divide both of these terms by so that I'll have square numbers left over. The one I've got here, 28x cubed take 63x, is just like the one above, only a little bit more complicated. There's another layer of complexity here. First up, let's look at the numbers I've got. I've got 28 and 63. They're both divisible by 7. And I think if I take 7 out at the front, I'm going to be left with some square numbers. And then you'll notice the x cubed and the x, they both have x in them, don't they? So if I take 7x out the front, if I do that, to get from 7x to 28x cubed, I would need to have 4x squared in here. And to get negative 63x, I'd need to multiply 7x by negative 9. So what I'll need to do now is to factorise this bit here, because that is the difference of 2 squares. So I'll keep the 7x out the front where it was. It's not going to change. And inside here, we're going to have the square root of 4x squared, which is 2x. Add 9 to that. Sorry, not add 9 to that, add 3 to that. And then 2x take 3. Top right, I have got another difference of 2 squares problem. The only thing is that the first term here is a binomial, 2x plus 1, but it's still all squared. So I know that if I get the square root of that number, it would be 2x plus 1. 2x plus 1, all squared, is 2x plus 1 squared. And then the second term there, the negative 9, would just become plus 3, square bracket there, and 2x plus 1 take 3. So what I've done here is exactly the same as I've done in the other questions, in that I found the square root of the first term and put it in the front of these two brackets, two big brackets, and I've done the square root of -9, or the square root of 9, and I've put that at the end of each bracket there. Now I'm not quite finished, because inside the square brackets I can simplify what I've got. So 2x plus 1 plus 3 would become 2x plus 4. 3 plus 1 is 4. And 2x plus 1 take 3 would be 2x take 2, because positive 1 take away 3 will bring me to -2. That's it, done. Oh, actually, am I done? I've noticed that they're all divisible by 2 in that line. I could put a 2 out the front and do x plus 2 there, and put x take 1 here, because 2 multiplied by all of that would double it. Of course, I've made a mistake there. If I take 2 out of 2x plus 4, I would be taking another 2 out of 2x take 2, and multiplied together they would make 4, so it should be a 4 out the front there. Okay, next one here. I've got 3x take 1 squared and x plus 1 squared. So, I need I hope I've got enough space here. I'm going to put 3x take 1 there, and I'm going to add x plus 1. Big bracket. That's the first part. Okay, it's the same as, way back over here, the same as that part up here. And then for the second part, I'm going to have 3x take 1, close that bracket, subtract x plus 1, close those brackets. And that is exactly the same from going back here as that part of that question. So just like in the previous question I did, I now am going to simplify everything inside the square brackets. I've got 3x plus x here. So 3x plus x is 4x. I'll put that in a bracket. And -1 plus 1, nothing, right? 0. So I'll just leave that like that for the moment. And then on the other side, I've got 3x subtract x, which is going to be 2x. And just be aware, it's really important, I'm just going to highlight this. This negative here is going to apply to both of the things inside this bracket. So just be aware of that and don't mess it up, okay? You really don't want to. Great. So it's 2x. 3x take x is 2x, and -1 take another 1 away is going to be -2. Okay? Now, looking at my answer here, I can see that I could probably take, I could make this into 4x bracket 2x take 2. But that's not quite as far as I can go. I still could take 2 outside of these brackets here, couldn't I? There's 2 could go into both of those. If I took 2 out the front and multiplied it by the 4, I'd have 8x bracket x minus 1. Okay, and that's it, fully factorised. So I hope that video has been a little bit helpful for you.